Okay, so we did factoring perfect squares yesterday. Today I'm just going to kind of re-go over question 6 on page 24, but kind of try to explain it in a shorter way because although our method worked yesterday, I felt like if you guys tried that method on a test, it might be a bit long. So let's try to shorten it down. So I'm going to start doing this question again by rearranging 1 minus 12a plus 36a squared as 36a squared minus 12a plus 1 because I feel like we're more familiar with this form where we have like our variables starting from the left hand side, like so the highest degree from the left hand side all the way to the right. Now that I rearranged it, now this is gonna be similar. The similar part would be I noticed that these are perfect squares, right? So how I did before, I try to find out what two numbers add up together to make 36a squared, or what can 36a squared break down into. In this case, it breaks down into 6a, right? And what numbers break down into 1? 1 and 1 work, so we can just say 1. So from here, now I have these two numbers. I think, okay, if I took these two numbers and I multiplied them together and then multiplied them by 2, what number would I get? And the reason I'm doing this is because I'm referring to the notice like the green writing I have right over there, where I have bracket x plus y bracket squared equals to x squared plus 2xy plus y squared. That's pretty much just squared double squared, if you think about it. So squared as in I square the first number, double square as in I pretty much the middle term is going to be the first and last number multiplied together and doubled, so times by 2, and the last term squared. So squared double squared. And that's the exact same format I have 36a squared minus 12a plus 1 in. So 36a squared is just a perfect square, and 1 is a perfect square. And how I know that, remember, is because I look at the my coefficients in front. If my coefficient is a perfect square, usually that means this is going to be a perfect square that I'm factoring. And the exponents also have to make sense as well. So either you have no variables, or you have a variable with an exponent of 2, 4, 6, 8, 10, 12, etc., etc. As long as it's like an even number that you can factor out nicely. So in this case, 6a and 1, those are the numbers we found. So we would just take those two numbers, multiply them together, and multiply them by 2. In this case, if I did that, I got 12a. But 12a is not negative 12a because I need negative 12a. So instead, let's try 6a times negative 1 times 2. And if I do that, I get 12a. And the reason I can do negative 1 is because, well, negative 1 times negative 1 is still 1. So that works out. So I would say that this would be my answer. 6a minus 1 squared. So that would factor out as 6a minus 1 squared. So just remember the pattern of squared, double squared. So instead of getting it as 6a minus 1 squared and like foiling the whole thing out to find out if our answer matches, like if our answer matches the original, all you can do is, because you already know that the first and last term are the same, and the only thing you want to find out is the O and the I in FOIL, just take the first and last term, multiply them together, and multiply them by 2. And if that gets you negative 12a in this case, then you should be in good shape, and you can stop from there and say that this is the correct answer.